Hello everyone, once again welcome to a new lecture where here we are talking about one of the conditions when we have some pure inductive load, having a motor having the high inductive system, having a low power factor effect, then the measurement of power can be effective very less. It means the error should be very large. How it can be happen, as we know, whenever the power factor or cos phi should be very low in case of measurement of power, then our formula that we'll describe in previous formula, that average deflection torque is directly proportional to average power P, and power is basically nothing but Vi cos phi. So if cos phi is very small, is cos phi is very small, then average power is very small, then deflection torque should be very small. So if deflection is very small, then current carrying by this is very small, and hence the pressure coil is fully excited in this nature. Okay, if current is very low, then voltage is very high. In that case, the inductance due to this pressure coil causing the greatest error in our particular low power factor system. So there should be some new type of wattmeter should be considered or should be made to compensate this type of low power factor errors. Now, how to be accurate or how to be adjust this compensation? So one of the two fact that if we connect, if in case of if we having a low power factor, the power as I say cos phi is small, then power measured to be very small, then current is very high in case of low power factor measurement. If we connect the pressure coil in parallel to the supply side, then it causes a very high error, as it will producing the large current that will flowing through the current coil. And if current coil having the large current, as in case of low power factor, so it will causing the large voltage drop across it with respect to the your load side. So this particular error, so for reducing this particular error, we will suggest that we have to be connect our particular pressure coil is in parallel to our load, isn't connected to the load. And second thing, we have to be connected a compensating coil in parallel to our current coil, or we say in series with the current coil, and in such that in parallel to our main current coil system. How should we connect it? We will say that in low power factor system we have to be connected our pressure coil on the load side. First most important thing, pressure coil must be in parallel to our load, in connected to the load, first thing. Second thing, particularly a small compensating coil should be connected in series with the potential coil to reduce the error due to the potential coil current, as we suggested in previous figure also. As you see in particular diagram, that the total current carrying by this current coil is I upon IP. Okay, so the magnetic field produced by this particular current coil should be I upon IP. If the sum of the current is a IP current, it will be given is going to the potential coil, it producing own magnetic field. The magnetic field IP and magnetic field due to I and IP will uh, opposing each other and accumulate a total current I1, that is a load current should be flowing through that your load current, and hence the potential coil error should be reduced. But most importantly, we will reduce this error as we connected your a potential coil across in series with a pressure coil. But the most important one of the more error should be there, that is due to the capacitance error. Okay, as we know that during the low power factor, the pressure coil is designed such that it having the load resistance to increase the current flowing through this, and increase the load torque. So the pressure coil in case of low power factor carrying the current of 10 times with respect to the high power factor measurement devices. So as the power factor is low, the pressure coil inductance error is very increases by this particular formula, Vi sin phi 10 beta. We discussed in previous segment also. So as phi power factor is low, phi should be very high. As phi is high, sin phi is very large, and it introduces the great error in our measurement of power. So for compensating of this, we will add on an RC filter or RC compensation effect, such that L is equal to CR square, as we discuss in error compensation effect also. So we will reduce the error in system, and hence it is the overall system or overall electrodynamic wattmeter for low power factor measurement devices, where we design a compensation coil which will be connected in series with your pressure coil to reduce the high current produces high current flowing in your current coil, and it's made a high voltage across the pressure coil also, and we connected a capacitor to reduce the inductive effect in the system at the low power factor devices. Now second thing, sometime we said we have to be we normally measure the power in 600 or 1000 watt or 2000 watt or 5000 watt also, but when we have to measure in megawatt, in case of megawatt, we have to be done we have to be connect we will wanted a CT and PT, current coil and pressure coil. So measurement of current coil, so as we see in this particular diagram, this current coil is in connected with CT, your current coil, and potential coil PC is connected with PT, such that the higher voltage and higher current in your high voltage supply line can be made to measured by using some instrument transformer. They will act as a range of action. Is one of the application can be determined. The error due to CT and PT, like a ratio error and phase error, can be accumulated in this particular in addition to wattmeter can be accumulated. So overall error should be very large. Okay, so it is one of the method where we use the instrument transfer for range extension of wattmeter. That's it. Thank you so much for this particular lecture, where we're talking about low power filter, one of the special action wattmeter, and the use of instrument transformer. We will extend the range of instrument. Thank you so much.